When I asked the questions, what is his message to the future developers or current developers, he said that let's turn legacy into a word that we can be proud of. So please welcome on stage our next presenter, Ray Myers, with Code Mending in the AI Age, with a warm applause from Chicago.
With patience, the most tangled cord may be undone. As he mentioned, I'm Ray Myers. If you want to get some more information about the hijinks we're going to get up to today, you can go to this. I'm going to show this again at the end. And I have a website more on the philosophy, which is called Mender.ai. I study legacy code and ways that we can work with it. In order to test my methods, my techniques, and my tools, I like to use extreme examples. So let's look at today's tangled code, or some tangled code specifically. Marvelous, absolutely incomprehensible. I love stuff like this. This was an entry to the 2006 International Obfuscated C Code Contest by a person named Andy Sloan, who has given me a lot of grief. What does it do? What could this possibly do? We surely cannot tell by looking at it, so we better run it. Compile it and run it, and a lot going on here. We've got some ASCII art spinning around. There's this 3D donut in the middle of it. There's a checkerboard in the background, and it's going to come around again. There's a scrolling banner. It says IOCCC 2006 International Obfuscated C Code Contest. All right, very impressive. How does it do all that? How does this little blotch of code do all that? I'm very interested to know. One, because this is just the sort of stuff I like, but for an important reason too, right? It's more than a game. If we can make something like this maintainable, then I fear no legacy code. So what if you inherited this? What if this is in your version control repo at your next job? What are you going to do? Well, you're going to have something that you can do, actually. And tools that will help me in such extreme situations are tools that I know that I can trust. Well, speaking of one tool I may or may not be able to trust, as I was first looking at this example, it was March of 2023, which you may recall is when GPT-4 came out, the first major upgrade of ChatGPT. And the conversations it was putting out had suddenly become very lucid. Its code examples had become astonishingly plausible. So what many of us wondered is, can this thing just do my job for me now? Are we done? So, sure, why not? Let's try it. Let's see, hey, ChatGPT, can you do my job for me? Can you improve this code? Here's this code. And already, it's so optimistic. I love it. Certainly, here's the improved version. It thinks it can do it. Excellent. And so it pops out some stuff that looks like code, and it talks about some of the improvements it made. And it has some good ideas. We don't have to look at that right now, because despite that it's saying here this version should be more understandable and maintainable, it's not more maintainable. It doesn't even compile. It's not even code. It just is code-like substance. But it did have good suggestions. And to be charitable to ChatGPT here, I wouldn't trust myself to modify this code either. And I would use my JetBrains IDE or some other automated tool to modify it in a safer way. So the new magic is not getting us all the way there. We're going to have to rely on the old magic, after all. Well, where do we start? You might guess some of the old magic we especially like is to have tests. And this code did not come with tests. You will be astonished to find out. So, fortunately, all it's doing is outputting some text with some ASCII control codes to reset the frame. So we can actually make an approval test that works quite well on this. So this is just a short bash script that will run that binary and take the first 5,000 lines and then send it to a log file. Then we're going to run a little sed command to turn the ASCII control codes into something that we can read and compare. And from here on, once we've captured that log file once, we save that as our golden file, and then we can run this test to prove that any future modification of this is, at least for the first 5,000 lines, which is a full cycle of the animation we find, has produced identical output. Great. We have test coverage. So a step that was before that even, actually, is that this code didn't even compile when I got it, because the compiler that I'm using is different than the one he was using. If you go through the International Obfuscated C Code contest entries, you're going to run into problems like this. And so there's, near the bottom here, one change I had to make just to make it compile. So we'll do that, which is the main method. See, that was a main method the whole time. Needs types on its arguments. K and Z are not what they should be called, but that will at least compile. But at some point, the C compilers that we work with stopped letting you just not specify. But they're always the same types. The first argument to main is always int. The second is always a char star star. So we can do that. I'm using some commit notation here. You don't need to worry too much about it, but I've got this scary @ sign, meaning that I've actually touched the code with my grubby little hands in order to add those types. I don't like to do that on code I don't trust, so I'm calling attention to it when I actually do that. Most of the changes we won't need to do that for. And then once I've done that, I can capture the log. Now I have test coverage on all further modifications. The first modification I'm going to do is another manual one, unfortunately, but I'm going to add a little sleep command at the bottom there. I have figured out through just guessing that there's a couple of closing braces, and so the last one has got to be the end of the main method, and the one before that, I'm probably in the middle of a loop. So I'm going to jam a little sleep there, and then it'll animate at an appropriate speed for the laptop that exists in 2024 and not 2006, and so it'll animate at the speed you saw. All right. Now we have tests, they pass, we can start doing more normal things with this. Let's format it. Now, we use Clang format, and normally we trust Clang format, but on code this treacherous, we cannot. I have in some situations found that on entries to this contest, formatting it, merely running the formatter will break the code. So we could run the test after that. Let's be even more dogmatic on that, because we have a higher assurance we can get. We can save the binary before we run the formatter, and we can compare compiling it after we run the formatter to know, actually, not only have we not changed the observable behavior, it compiles to the same bit-for-bit binary. So, binary identical, we are now in business, and we have something that at least looks like code. We may not be able to read it and understand it, but this at least looks like code and not ASCII art, so that's like we've gotten somewhere. So ChatGPT is going to start helping us now. But we've already established that it cannot reliably give us updated code that will work. So we're only going to ask it for suggestions. I'm going to prompt it to say, hey, just tell me what you would do. Don't give me the updated code. Just tell me the things I could do, and I'm going to give you some actions that I'm able to execute in my IDE safely. And we'll add those implicit types we mentioned earlier. Again, binary identical. So now we start to get the suggestions from ChatGPT. ChatGPT suggests astutely that render glyph is a better name than P for this function. I mean, that'd be perfect. It's better, right? That sounds pretty good. I'll go with that. We'll accept that. It suggests rename this variable N to be numglyphs and this thing called C to be glyphcar. Plausible. I might take that. It wants me to inline the ternary operators. We've got a nested ternary operator. I probably don't like that, so that sounds reasonable. And then it says to extract it as a separate function inside there. It's calling write to buffer. I don't know what it's talking about with that. I'm probably not going to take that suggestion. But anyway, as we execute this, we're going to use our JetBrains IDE. The version of IntelliJ that's for C is called CLion, if you haven't seen that before. But generally, we want syntactic transforms wherever possible to do our modifications. So, great, we've renamed it, and references to it have also been renamed. And our tests pass. All right, we still have incomprehensible code. We'll do the next two renames. we can understand in line what some of this might be doing, almost, Take a few more recommendations. Okay, it's identified a global O that it would like to call an offset, probably because somewhere else in the code it was being used to index an array. All right, we'll take that suggestion. And I'm going to use clang tidy to add optional braces everywhere they can be added. That's going to help us a little bit. Because, when you've got code that looks like this, it's hard to even tell if it's one line within a construct or not. All right. Changing the ternaries to a nested if, which I believe the IDE was able to do for us. We're changing a global from underscore to stir index. Stir index is still a little vague, but I will take it over underscore. I like that change. We're renaming another global. B is now frame buffer. Now, that's going to add quite a bit of insight because B is dereferenced all over the place. And knowing that every time we're messing with that array, we're actually looking at the frame buffer, like this is what's going to eventually go on the screen, that actually, if we were to scroll through the code right now, makes a huge difference in our ability to understand what's going on. We're going to extract a constant. Now that we're reasoning about the dimensions of frame buffer, this one constant is revealed to be frame buffer width. It's 80. That makes sense. We're in an 80-column terminal. It passes my smell test. It's changed offset to buffer offset. I could take or leave that one, to be honest, but whatever. We'll go with it. Extracting some magic numbers into constants. So these are from various places in the code, and you can see the updated places where you're now able to see a little more about what's going on. We talked about why we would know this is frame buffer width. Now, why would we know 6.28 is 2 pi? Well, that's domain knowledge, right? It's roughly 2 times pi. It's not exactly, but if it's being used in a trigonometric situation where we're drawing a circle, I think it's safe to say that 2 pi is the reason that 6.28 has appeared. And theta step is a magic number. We're just divining that that's what we're calling this because we've named something theta at some point, and that's what we're incrementing it by. So it's still better, but, increments. Anyway, I've told you I've been getting these recommendations out of ChatGPT. I haven't told you how I actually prompted it. Now, if you wanted to, you could go to the GPT's store and you could use a newer version of this that's kind of interactive called Refactor GPT. But I don't actually recommend you use that version. I recommend you build your own, as I did last year, and I'm going to give you a slightly updated version of it here. And so I'm not taking you through this for you to copy this exact prompt, but just to understand how I go about constructing it. So first I'm saying you are an expert in software engineering, including maintainability and refactoring. So I'm getting it in a mood. I'm pointing it towards part of its training set and setting up a little role-playing exercise. That's a common prompting technique. I'm saying for every block of source code you're given, suggest several opportunities for renames and other refactoring. So I'm giving it a clear idea of the task it's going to do, what kind of input it's going to get. I'm going to give it some constraints. You will very quickly see when you give these things prompts that they start doing things you don't want them to do. Like they show the updated code, and even though you didn't ask them to in this case, for example. So I say, don't do that. Be brief. It's being too long-winded. Things like that. So I'm going to put constraints based on the undesirable things I've noticed it doing. I spend quite a bit here talking about the structure of the response I want. These are the types of suggestions that I would encourage you to make. This is how I want you to group them. I want you to group the suggestions by the method they appear in. So if I give you a large block of code that has several different functions in it, you're not going to give me a name that's ambiguous that maybe appears in multiple different scopes and so on. You saw earlier, you might not have been paying attention to the details, but it wasn't giving as good of a rename format in the old snippet because it was saying change A, B, C to new name A, new name B, new name C. I obviously want one per line so I can quickly read it, right? So we give it a clearer idea of what we want out of it, and we have a more serviceable prompt. Anyway, back to the code. So you saw a very small part of this. Let's go to the biggest part. Go to the bottom, and let's look at the main method of this. As it's first formatted, this is what you C, and this is some of the suggestions that came out of ChatGPT. It would like to rename underscore X, Y, O, and N to the word underscore, oddly, X pose, Y pose, offset, and N value. So first one and last one, I don't like at all. The rest of those I could take. So I'm still having to use my judgment here. It is decided A and B are angle A and angle B. Now, angle A is not the most descriptive name in the world, but I do like that because it's being passed into sine, it's being passed into cosine. These are definitely angles. So naming them that's good. That is one valid thing to name them. You know something about what they are. You could later figure out more specifically, but it's also suggested to rename the function E to render donut. Now, that turns out to be wrong. We're going to end up undoing that later. But I didn't know any better at that point because it was still called E. Things were called single letters. And it wasn't clear to me at that point that that wasn't the part that renders the donut. But that was something we will have to backpedal on. OK, so we're splitting the initializers. Again, the IDE can do that for us so that there's not X, Y, Z being declared all in the same line. We're executing a number of other renames. E is becoming sine A. So again, we start with A. We don't really know what it is other than it's some angle. And now we've got some other variable. But if we call it sine of A, we can at least relatively reason about what's going on. We end up with things that look somewhat like equations at the end of the day. And our limitation in understanding them is no longer that the code's been discombobulated. It's that just our lack of understanding of trigonometry, maybe. It's been many years since I've taken these classes. So we rename all these. You saw the rename from B to frame buffer earlier. And we see a blob that we might want to take out. I think this one was me. I don't think this was a ChatGPT suggestion. And so I'm going to extract this. And the one thing I'm sure about is that it is updating the frame buffer. That seems to be the main side effect that's occurring here. So we'll extract update frame buffer. By this point, I have figured out that render donut is actually rendering a banner. So it's responsible for a different part of the animation. And there's another blob here, which I'm extracting to render checkerboard. Now, how could I look at that and say that it's rendering a checkerboard? Not by understanding the logic just yet, I assure you, but what does it ultimately put in what we now know is a frame buffer? Either a dot or a hash, based on this strange offset here. So it's taking either a dot or a pound sign and putting it into a frame buffer. If you looked back at the ASCII, you would see that the only thing that could be is the checkerboard. That is the thing that is constructed entirely of a dot and hashes. So that's why we know that blob must be rendered checkerboard. So we'll put it up there for safekeeping. Now, I dare say main is looking quite maintainable at this point. I'm fairly happy with having gotten it this far. There are still some bits that are mystifying to me, right? Is these magic strings here. Why are we doing a puts /x1b open bracket 2j? I haven't done ASCII control codes in a long, long time. I don't know what this is. I could go look this up. I mean, we know how to learn these things. But also, this is a relatively good time to use ChatGPT as well, right? This little tiny invocation. You need to tell me what this does. And ChatGPT happily tells me, well, that is clearing the terminal screen. And these are the components of it that make it do that. And then at the beginning of every loop, before I update, before I print new characters, what does the second part do here? Well, it moves the terminal cursor to the home position. OK, does that pass my smell test? At the beginning of this, we're clearing the screen, and at the within every loop, we are going to move the cursor to home. Yeah, if I was drawing a 3D animation out of ASCII art, that's definitely what I would be doing. So I will accept those comments. Good suggestion, ChatGPT. So let's see what the code looks like now. We've got a bunch of constants, some global variables that if we wanted to, we could pass them around, manage the state a little bit better. Some signatures. We've got our main method. There's definitely more parts of this. Okay, this code gets a little slow to animate. There's just a lot going on here. All right, great. There's this other thing, code to index, which admittedly we have not figured out yet at all, right? And I'm not sure if we would continue to go through this refactor rename cycle if we would get very far. So there are limits to this. Render banner, also involved with code index and the render glyph function. So again, we've got it to where it's like, we can see some of what's been going on, but there's some mysteriousness left here. All right, render checkerboard. I think if you looked at this for a little while, you actually would be able to see how that was done. And most of main I've extracted out into render donut. And again, this is more limited by our understanding of trigonometry. Andy Sloan has a good blog out where he talks a lot about the actual geometry going on now. But as far as the code untangling, this is pretty near ready. I mean, it's not the best code in the world, but we could start working with it at that point. And I've demonstrated that, at least to myself, by adding features to it and things. Minor utility function, print frame buffer. All right, so we'll declare victory at this point. There's a longer version on YouTube. But what have we used here? A lot of different things together. We've used myself, certainly. We have a human expert in the loop. We have GPT-4 providing a small but very helpful part of the process. I have done similar exercises to that without it, and my brain hurts a lot more than when I was able to offload some of this. And we have a lot of algorithms, right? We have refactoring support provided by our JetBrains IDE. We also have code manipulation that's being done by ClangTidy, configured fairly carefully. By the way, that's the logo for Clang, that flying dragon. I didn't know that till today. It's pretty great. We're also using some discipline practices, which are pulling a lot of the weight here. So I don't want to downplay that. That's probably the most important thing that we're doing here. Some pieces of this are naming as a process. Arlo Belshy's written about that, also as read by refactoring. We're doing test-driven development in a sense. In fact, you could say we're doing test, commit, revert, Kent Beck's strengthening of test-driven development, in the sense that, like, if we take any one of these steps, we should be able to commit right after, and if it were to fail, we should immediately undo it. So I'd say when you're doing incremental refactoring, test, commit, revert works very well. We're also using approval testing, or golden file testing, you might call it. And an interesting thing here, a human almost never directly touched the code. Only in a few situations that I called out did I directly edit the code. And we've got it to a part where it's understandable enough that I might feel comfortable doing so. But at the beginning, I certainly wasn't comfortable. And we definitely never had an LLM directly touch the code, only make suggestions that we applied using an algorithm. So the core cycle that we happen to use here, as I mentioned, was an AI suggests. I vet these suggestions, toss some of them out. We use the IDE where possible to refactor. We run tests and then commit a single change. This works pretty well manually. It was already an improvement having the suggestions in the cycle. Once you get automation attached to this to where just doing the automated refactor and running the tests and committing is its own fully automated step, and you're only just choosing the suggestion, it's amazing. And I've actually been surprised that in the last year, there has not been a polished tool that does that. We will see that. I'm convinced of that because of how effective it is. This is not for you to memorize that exact process. You'll be constructing your own. But the dominant approach to using AI language models for software development is, I believe, fundamentally flawed, which is to take that broken LLM output and copy-paste it into production. That may work if you're on brand new code. It doesn't work in the bulk of our work. So these two flawed assumptions are assuming LLMs can reliably write code. They couldn't a year ago, they can't today, they can't next year. They're simply the wrong kind of tool, and it is not their fault. And two, there's this assumption that writing new code is the core problem that we need to attack. Actually owning all the old code that we have is the important problem to attack. So if you invert these two assumptions, you now have a recipe for some really positive change. This part is important. Admittedly, these chatbots have some pretty spooky, pretty scary capabilities. And it's hard to tell what they can and cannot do because we have never seen anything like that able to use language so fluently that didn't also have a brain attached to it, which they happen not to. But seeing these things, everyone has wondered, maybe for a moment or maybe for a month, am I still relevant? Does the world still need me? I've done all this work. I've learned all these things. Does the world still need me? But I flew here today to tell you that actually the situation is even more dire than that. Because not only does the world still need you, but it needs you now more than it ever has. And I don't just mean humans, and I don't just mean programmers, though I do. I mean a lot of the people in this room. People that have studied the craft in detail, who have thought deeply about what holds software development back. Because we cannot make it better without understanding that, no matter how much magic they give us. So, before ChatGPT, I did a version on a much simpler donut code, and then someone pointed out that I had broken it trying to mess with it, and so I did one with tests. And then after ChatGPT, I was finally able to take on the one that had won in the International Obfuscated C Code contest. And sure enough, I summoned the author, Andy Sloan, comments on my video. Hey, it definitely does understand how the donut rendering works. It's getting parts of this right. I'm not sure how much it was contaminated by his blog post on that broke it down. So this is always something you got to wonder whenever you're seeing the capabilities of these things. Is it just training set contamination? He raised some really good points. He went through it actually in some detail. I have tried this on other examples, and I can assure you this is a valid approach. There will be things that are reflected better in the training set and worse, and that is simply how it functions. But when you're updating legacy code, you are very often messing with stuff that is somewhere in a training set somewhere, right? Or similar to it enough. But he adds this, ominously, I'm amused and somewhat satisfied that nobody's figured out or told me how the logo is encoded in 15 years, and ChatGPT can't either. And he goes on, but darn it. I was so happy with myself for getting that far, and now he's pointed out that not only did we totally punt on the Bander rendering, but nobody's gotten it, and it's been 15 years? Well, I can't let that slide, obviously. Obviously I can't. And 6 ways from Sunday, we can ask ChatGPT, hey, what's this code that we've now untangled partly doing with this string? How's this becoming a Bander? No help at all. I'm on my own. 6 hours later, I am now able to tell you how this ASCII logo becomes that, or how it is decompressed from that. And it would be a whole talk to take you through exactly step by step what the code's doing and how I reverse engineered it, but I was able to come back to him the next day with roughly this solution. So if you have taken computer science formally, you will understand some of the words that are at work here, but it starts by doing something like run length encoding, right? So you can see at the beginning there's 1 dot, and then there's 11 underscores, and then there's 2 tildes, and then there's another 9 underscores, right? So that's the run length encoding that we do to start. And we're doing something called Huffman coding, which uses fewer bits to represent things that happen more often, to compress the rest. There's Huffman tree on both the characters and the run lengths, which is kind of an odd approach. And then we take that Huffman-coded binary string and break it into 6-bit blocks. Out of sheer enjoying other people's suffering, using those blocks in least to most significant bits, so completely the opposite of what a rational person would do. and then converting those blocks to ASCII using the characters from greater than sign to tilde inclusive. So there are 64 characters to use, and so if you have 6-bit blocks, you can use ASCII in that range to encode it, and that is how that banner becomes this magic string that appeared in that code originally. So I came back, yes, okay, I think I get it now. Run length encoding with Huffman trees and yada, yada, yada. He's like, yes, you got it, finally, somebody got it. And I was the first person after being up for 15 years to do so. Thank you, thank you. With no help from ChatGPT, but better luck next year on that one. And I will now prove to you that I did in fact do it by changing this string with another magic string, which I would only be able to do and get a result if I had really, truly understood the exact encoding process. So we're going to substitute it with a new string, compile it, and run it. All right? And instead of IOCCC 2006, it says Craft 2024. Replacing the donut with the Craft logo is an exercise left to the reader. With patience, the most tangled cord may be undone. Thank you.
That was really, really great. So let's check the questions. What kinds of refactoring are hard to offload to GPT?
Well, obviously at the end we saw something that was difficult because the person had done several different layers of screwing around with it. So in general, things that require multiple cognitive steps, right? It's not going to do an arbitrary level of quote-unquote reasoning from what's in its training set. You're usually going to get, one step. So I would say, read some Martin Fowler, learn about how to break down any change you make into very small safe steps. I've been, kind of using insanely small steps with this. And you're more likely to succeed. But generally, coding is not one task. When we talk about whether an LM can code or not, coding isn't one thing. It's many, many different cognitive tasks. So any refactor that is going to require many steps sort of at once, try to break down your cognitive process because you're not going to have a great time usually.
Okay, another question. The core part of this is having robust test coverage behind the code base in the first place.
I certainly started there because I like to set a good example, but you notice I wasn't even touching the code by hand for almost all of it. It is actually possible often to make automated changes to untested code safely. There are ways in which you can mitigate the risk in other ways. I've even done on my channel, I have a version of Gilded Rose where instead of using automated tests, I used formal methods. I used proofs. And so there's lots of different ways of reducing risk available to us. And simply not editing the code manually is one of the really nice ones I would suggest. Have tests if you can, but that can get you around it. That can get you to a point where you're in a structure now where it's easier to do tests.
Okay, I have a provocative question. Did ChatGPT come up with the render donut suggestion? How did it know about the donut? Is that a sign that it might have been contaminated by the blog post?
Yeah, so in Andy Sloan's comments, he left several more talking about what might or might not be contaminated, and I think it is plausible, though we don't know, that there could be some contamination in the particular names, it going right to it being a donut instead of saying that it's a Taurus or something. But the reason I still present this example is because it is reflective of how useful it was on other examples where I do have reasons to believe that it wasn't contaminated. And actually, if you look at the refactoring literature, there are actually academic papers from years ago where they've trained neural networks and used other kinds of techniques to do successful recommendations of refactoring. So we didn't even have to wait till ChatGPT to be able to do this kind of thing. We just aren't up to date on the literature.
Great. Some tips on doing something similar, but with way more code scattered around different files?
Yes. So you do have to be smarter about how you manage the context window. I'm using their code that like you can fit it all in a single prompt, but because I'm using automated refactoring tools, which can operate on a scaled code base, the technique does scale up. We just have to think about where do we want to direct its attention and how much context do we give it. But these are solvable problems. They're just architecturally a little bit tricky.
Okay, one other question from my side. What happens when the models get better?
Yeah, you get this a lot when you talk about, hey, it's breaking the code, and I'm doing more than just complaining that it breaks the code. I'm offering alternative workflows where it won't, right? But some people will just rush to the LLM's defense, or they'll talk about, hey, it's going to get better next year. Whatever you're thinking about that it can't do now, it's going to do it next year. Notice how I skipped a step of reasoning. It is going to get better next year. That doesn't mean you just get to say whatever it's not doing, it's going to do next year. You need to make your tools better next year using better capabilities, but right now we're limited much more in how we use these things than on how good the actual models are, and they are going to have inherent weaknesses regardless. There are going to be categories of things they are the wrong tool for.
That's great. I don't see any more questions in Slido. We don't have any.